For more problems and videos like this for linear algebra, you can take a look at Sarai Studies. Link is in the description box below.
So let's say that this is your matrix and you want to find the determinant of it. You see that it's not a 2 by 2 and it's not a 3 by 3, so it's not like you can easily find the determinant. So what do you do then? Well, we have this method called cofactor expansion, and it goes like this. The first thing you want to do is pick a row or column that has the most zeros. This is the row that has the most zeros. Then what you want to do is you want to pick any number. I always start with the first one, but since it has a 0, I'm just not going to do that. I'll just start with the non-zero number, which is a 3. So what this means is that the determinant of matrix A is going to be 3, because that's the number we pick, times the determinant of whatever's left when we cross out the corresponding row and column of the number that we circled. These numbers right here. So that's 1, 2, 4, 0, 2, negative 3, 2, 0, 0. So you're just copying this matrix, but just ignoring the numbers that you crossed out. Then there's one more thing that you're missing. So for every coefficient that you pick, there's a corresponding sign that's going to go here. And no, I'm not talking about the sign in front of the number. I'm talking about a separate sign. And so the way that I determine what that sign is I use this thing called my little helper tool. And it's going to be a matrix of the same dimension. So this is a 1, 2, 3, 4 dimensional matrix. And this is also going to have 4 rows and 4 columns. And it's going to start with a plus. And then I'm just going to continue the pattern, plus, minus. And then when I go on to the next row, the sign that goes here is the opposite of the one above it. So that's going to be minus. And then you just continue the pattern, and then again opposite of this one is plus, then continue the pattern, and then opposite of this one is minus, and then you continue the pattern, and so on. And so the corresponding sign of 3 is in the same spot, right? It's 1, 2, 3. So second row, third value is this one. So that means we're going to put a negative right here. And so at the end of the day, the determinant of this matrix A is this, but this is based on the determinant of this, so then we have to go and solve for the determinant of that. Now I see that this is a 3 by 3 matrix. So cofactor expansion works on any dimensional matrix, so you can choose to do cofactor expansion, but I know that for a 3 by 3 matrix, there's another way to do it, a special way. So I'm going to copy that matrix, and then remember the way that we do it is we focus on the top numbers. So the first one, you go down until you select 3 numbers. Second top number, you go down until you select 3 numbers. Third top number, you go down until you select 3 numbers. And then all you're doing is just multiplying these numbers and then adding them together. So here, this is all being multiplied by 0, so it's just a 0. Here, this is 4 times 3, negative 12. And then here, this is being multiplied by 0, so it's just going to end up being 0. And then you focus on these top numbers. So we focus on this first top number, and we go down until we have 3 numbers highlighted. Second top number, go down until we have 3 numbers highlighted. Another top number, and we go down until we have 3 numbers highlighted. But then this time, when you're dealing with these numbers, you're going to subtract. So when you multiply these, this is 1 times negative 3, that's just negative 3, times 0 is just going to be 0. Then here, this is all being multiplied by 2 zeros, so it's going to end up being 0. And then here we have 16. And so this here is really just this right here. So I know that these are all irrelevant, and so it's just 12 plus 16, which is 28, and it's a negative. So this is going to be negative 28 times negative 3,
Which was 84.
I'll show you what happens. If I had done cofactor expansion again, I would have chosen the row with or column with the most zeros. To me, that's this one. And then I would have chosen the first number, 2. I would have found its corresponding sign. So that would be this one. It would be a positive 2. And then we're doing times the determinant of whatever you get when you cross out the row and column. So 2, 4, 2, negative 3. And so ideally, this would have ended up being negative 3 times this. So positive 2 times the determinant of this, which we know is just 2 times 3, which is negative 6, minus the product of these two numbers, which is 8. So this here is negative 14. This would have been negative 28 times negative 3. That's still 84. And remember, the way that we generated this is the same way we generated that. We start with a plus, and then you just continue the pattern, plus, minus, plus, minus. And then when you go to the next row, you just do the opposite of what's above it. So that's it for this video. I'll see you in the next.